Welcome, everybody. We're here today to talk about empowering tech entrepreneurs, harnessing a large language model in Power Platform. So I'm Stott. I'm a principal cloud advocate at Microsoft. I work within the new generation, the growth and ecosystems team. I'm an advocate who runs the AI and the low-code team. I'm here today with John Aziz. John is one of our gold student ambassadors. So John, do you want to introduce yourself?
Yeah, thanks, Lee. Hello, everyone. Welcome to this reactor session. I'm John Aziz, and I'm from Egypt. I'm 23, a computer engineering graduate, and I am really passionate about AI and ML. So glad, so glad to be here with you today.
Excellent. Thanks, John. So yeah, today what we're going to be doing is looking at a set of different solutions to really get you, number one, introduced to what large language models are. We're going to focus all of this around a use case scenario so that this is going to be a complete system that you can build and that you can then replicate and actually utilize. We're going to look at how LLMs are deployed. We're going to talk about the Azure concepts because we're going to use a service called Azure Machine Learning Studio to do this and use the large language models within the model catalog within Azure Machine Learning Services. And we're going to actually do a practical deployment of a large language model using the Azure Machine Learning Services. We're then going to talk a bit about the Power Platform concepts, talk about what Power Platform apps are and how to utilize Power Platform apps to connect to endpoints. And we'll do a demo of the actual implementation using a Power Automate Cloud Flow. We'll then talk about the Power Platform app itself. And then we're going to wrap up and do a bit of a summary. And then we're going to be open to questions and answers. So please use the chat boxes available for questions and answers. And we'll try and answer as many as we can when we come to the end of the session. This session is going to be rather packed, as you can imagine. We've got lots of stuff to go through. So first of all, we're going to start off with an introduction to LLMs. So John, can you give us a bit of a background to what LLMs are and how they're utilized?
Yeah, definitely. Let's get started. So let me give you like a brief overview of how LLMs works. So simply put, any language model takes text as input and it produces more text as an output. Yes, can you click again? So if we give a robot, can we go back to the previous slide? If we give a robot some words, it's going to try to formulate a model to understand this few words and generate more words based on the possibility of a word coming after another word. So if I say the dog is playing in the, a robot or a large language model is going to try to recognize the pattern missing from this sentence and generate more words like maybe the dog is playing in the park, maybe it's playing in the woods, maybe it's playing in the snow, or playing in the office. What do you think it might give us? So that's what moves us to the next slide, please, which is that how does it choose between all of these words? What does it do to pick the best or the worst, or which are words should I choose? So it asks itself this question: what are the different probabilities I have? So it gives a probability for each word that might come after a specific word. So let's take this example in front of you. During holidays, what do I like to do? I maybe like to play or sleep or fight. So what are the possibility of the word or the probability of a word called play coming after another word, which is I like to? So it takes these different probabilities and compares between them till it gets the best one. Like, for example, here, it needs to complete this sentence. So it's going to choose the word play with my dog. And of course, it's not going to fight my dog or sleep with my dog. And it is so cute. Is it true? Is it not? Yeah, that's, of course, something cute to do, which is playing with your dog. Next slide, please. But how does LLMs work? So we have seen how normal language models work They are just based on the probabilities. So the LLMs work, and you are going to get to know this more deep with Lee in the next slides, is that it's based on something called the attention. And the attention makes your model focus on a specific piece of information that you are giving it. So it's not gonna take the big picture, or it's not gonna take everything literally. It's gonna focus on the big picture instead. So it's gonna focus on specific parts that are, or that needs attention to understand, in images, in text, in voices, whatever you are giving the large language model, it's going to try to focus on it, and it's going to make a mask like you see in the image. So for example, if I'm trying to recognize that something that is missing from this image, so I'm giving it, or it's generating this text, okay, which is missing some words. A woman is throwing what in a park? Based on this image, the woman is throwing something, and you can see it did what? It focused on what the woman is throwing in the picture. It ignored all the other stuff. It graded out. So it is focusing on the missing word, the missing piece of information. It doesn't have to process all the image to know what is the woman throwing. It just needs to focus on one specific part or parts, like all the rest of the images here you can see. So that's how it works from a higher perspective. And let's see what Lee is going to give us from like a deeper perspective on how it works.
Thanks, John. So yes, as John was saying, what the machine learning model is actually doing is doing a prediction. So it's using different weights to then analyze what that next word should be, or it's looking at the actual image and then doing a deep analysis of that image. So if we look at the two different frameworks for different machine learning models, there's a thing called attention. So there's a sequence called RNN, which is recurrent neural networks. And what they are is an attention mechanism of both components used in the machine learning model, but they serve as different purposes and have a distinct characteristic. So what I want to do is explain the difference between RNN and attention frameworks. So if we break this down into different components, if we look at what the purpose of the model is, what the architecture of the model is, how handling is actually undertaken by each of those, and then how parallelization works. So this is going into like the fundamentals of machine learning. So an RNN is really designed for sequential data, and it has the ability to capture dependencies across each of the different steps. So in this example, we're doing some pattern matching of words. So we're taking Chinese language to English language. So that's looking at a pattern. They're well suited really for tasks like natural language processing, which is shown in this example, or time series analysis, because we want to understand a step within a designated pattern. Things like speech recognition are also useful, and where we have data in sequential order. So that's really where RNNs have massive advantages. Now, if we look at attention mechanisms for a purpose, they're really used to focus on specific parts of input sequences. So when making predictions, that's where they're really good, because you're actually predicting something using that multi-headed attention layer. And really looking at, they're well suited for tasks like natural language processing again, but they're really useful for things like long sequences and where you want to capture non-local dependencies, which can be challenging for non-standard RNNs. So the two slightly different purposes for what we want to do with each one. And again, if we look at the architecture, the architecture of RNNs are really about a recurrent structure that allows them to be easily maintained because they're very simplistic in their structure. They have a hidden state that carries information from one time step to another time step. And this makes them really capable of handling sequential data from a processing of one elements at a time and updating their internal state. So they're very sequential in their approach. Whereas attention mechanisms are typically used in conjunction with other neural network architectures. From time to they're really looking at how they use things like transformers. They work by assigning weights to different parts of the input sequence. So they're actually measuring what characteristic that input sequence has, giving it a weight, and then classifying where it should go next, which really enables the model to selectively attend to specific elements of the class. So really good at large scale problems. Then we look at like the handling and long sequencing. So what we really want to do there is RNNs do really suffer from a vanishing or exploding gradient problem. So this is, what is sometimes seen as when false data is given because the machine model cannot understand what the actual query is being asked for. And there, this is really making it challenging for them to capture long-range dependencies effectively. Whereas we take attention mechanisms, they're much better suited for handling long sequences because they have the middle layer and they can focus on relevant elements without vanishing gradient issues. So this makes them effective at capturing long-range dependencies. So that's really key to really get that to work. So if we look at parallelization now, parallelization is really looking at the focus of the sequence of data which can be utilized. So RNNs have a very limited set of range. So the parallelization capabilities make them slower for transitioning, whereas attention mechanisms can be parallelized more effectively when to speed up training for suitable models. So it really depends on what you want to do to which model you should utilize. But things like transformer mechanisms allow you to capture both sequential dependencies and non-local relationships within the data. And the choice between the mechanisms really depends on that task that you want to undertake. So again, these are the two key models that are available today. So if we look at, auto-regressive models, auto-regressive models are really the key to what all modern machine learning is really based upon. And this is really, it's abbreviated as AR. So sometimes you see a statement called AR. And this is really about things like time series forecasting that predicts a future variable model based off a known input. So look, if you look into linear combinations of previous observations, this is the way this diagram is showing. It's really looking at how it can do predictions and looking at what that outcome should be based on those layers it's going through to identify the pathway to that desired outcome. So auto-regressive models are used for observations from past to predict the next value, but they're also limited by a number of things. So they're limited by linear assumption, so trying to understand that pathway, different order selection, so when you're putting data into the models in different ways. They do require stationary data, so they're not good for dealing with data that is growing and is changing on a regular basis. And they have sensitive output layers. So, they're suitable for short to long-term forecasts because, your data's pretty stagnant. They're, again, really good at, capturing seasonally trends, so you can actually use them for modeling. They're not very good at handling complex dependencies, and data availability and the lack of explanatory power is also another issue. So if you look at the difference between sequential and generative, a good distinction is that generative and sequential describes these types of models. And what is really key is about auto-regressive. It describes the models and what they do. It describes the properties and the network and the architecture. So this is what this diagram is really trying to explain is, these auto-regressive models are based on a persistent architectural model. So if we look at auto-regressive decoding, and auto-regressive decoding is like really where we are today in terms of modern machine learning programs. So things like, Llama 2, GPT are all auto-regressive, and that's what we're going to be talking about today in terms of LLMs. They are based on an auto-regressive model. So auto-regressive decoding is a process for generating a sequence of tokens at a specific time. So where each token depends on the previous generated token. So you're building upon those suggestions. So in this example, it's like the dog. Then what's the next suggestion? So it could be sat, it could be ran, it could be hid. So it's using those predictive models to add to the next step. So when a generative textual sequence with a large language model begins to use, it's really using the prompt to then follow the steps shown in this image, to build that whole sequence up. So we're using the large language model to generate the next token. And then this input token is our output token for the next sequence. So you're building in terms of like a prompt to keep growing, the actual output. But by continually generating the next token in this matter, it's what we call the autoregressive decoding process. So the process is how that next token is being created. So we end up generating an entire textual sequence by just doing the input, output, input, output, input, output, and using the predictive model to then suggest the next statement or next word in that model. So we end up with a final outcome of the dog sat down, or it could be the dog sat on the map, depending on how we wanted to process it. So, the question we have is, how do we choose and predict the next token? I think that's the most challenging thing that people go, well, how does it do this? So step one is shown in the image, it looks at the architecture. It then, instead of directly outputting the next token, the language model output looks at the probability distribution. So when John showed his slides, it had percentages against each word, and that is the percentage of probability that this should be the next word. So simply put, LLMs are essentially a neural network tackling a classification problem over vocabulary. That's the easiest way of doing it. So they're looking at unique tokens. So given this probability distribution, we can follow several different strategies for selecting the next token based on the weights, based on the temperature. And we'll talk a bit more about weights and temperature in the next few slides. But then we can actually then understand how these models are created based on how you can change the temperature and weighting of these. And this is where things like Bing Chat and if anybody's used ChatGPT, you can change the weightings, which then make it more creative, or it makes it more factual in its output. So John, back to you to talk about these techniques of P and
Yeah, so what are the different techniques that we can use to predict the next word in an autoregressive decoding only manner like Lee showed you before? So in the most basic form, the first way that I can predict my next word is sampling. And sampling means that I will randomly select the next word, which is the word with the suffix of T, according to its conditional probability distribution. So what is this big word, conditional probability distribution? So it means that I am not selecting a word just based on its probability. I'm selecting it based on its probability, considering the next word probability, or giving the word after it. So in order to select the next word, I need to consider the previous selected word probability to be able to select the next word. So that is what conditional probability means simply, that I am not just selecting based on probability, I'm selecting based on probability and a condition. So taking the example you can see here, the following graph visualizes the next word when using sampling. So the first word that someone might select is the. Then I need to select the next word based on it, which is car. So I'm gonna select the word car, giving that I have already selected the word what? The word the. This is sampling basic, like 101 sampling, okay? So I am not deterministic, yani my generation is not deterministic anymore. Why is that? Because in order to select the next word, I need to consider what I have selected previously, and I don't know beforehand what I'm going to select previously. So it's not a deterministic process. Each time, like, I'm deciding what will be the next word based on what I have already selected. So I selected the car, then I'm gonna see the words or the pool of choices that I have to select from, and based on it, I'm gonna select what? I'm gonna select the next word, which is drives. So I have already selected the word car based on that, and I have selected drives based on the car. So that is how conditional probability works. So this is the word that I'm going to select. The next word equals the probability of the word and the word that is been selected previously to it. And we're going to get to this t. You can see there is a small t here. But what is this? We're going to get to it in the next slide. So in transformers models or autoregressive models, we do something called do sample equal true to enable this process. So next slide, please. So this is the t that I have been telling you that we will get to in the next slide. So this is really interesting, and the text seems right. So what we have chosen before is the car drives. But is this text makes sense to you? The car drives itself, maybe Tesla does, but it's not very coherent and it doesn't sound like a human wrote this text. So the big problem when we do sampling is the word sequences. The model often generates incoherent gibberish. And this is based on, I don't know if you can, but it's a paper that we might share with you at the end of the session. So in order to mitigate this issue, which is the model generating gibberish, we use something called the temperature. And this temperature makes our prediction sharper. So I'm not just predicting the next word, I'm predicting the next word based on a threshold I set. So if the next word probability is lower than, let's say, 59%, I'm not going to select it. It's not going to be in the pool that I can select from. So I increase the likelihood of specific probabilities to happen based on the threshold I set, and decrease it for the lower probabilities or the other probabilities that I have lower than my threshold, which is the T. So this T is our threshold or our temperature, that based on it, I'm going to remove some words completely because they do not meet my criteria. I'm going to make the others show up or glow to be selected for my model. So instead of it selecting the car, as we saw previously, the car probability was 0.1, so it's very low, but it got selected because of the non-deterministic and randomly selecting things. Now it is like it has been deemed like it's not going to be selected in the pool, and it selected what? Selected the higher probability, the nice. But again, the problem occurred again in the next one, and it selected the lower one, which is the house. So that is just to keep it random, to keep the model creative. Each time you give it or you try to predict some words, it's going to give you something new. It's not going to give you the same things over and over again. So that's simply put how the temperature works. And
a really interesting point on this, John, is when most people's experience of temperature today is things like Chat GPT or Bing Chat. So temperature is when you actually open up your browser for the first time onto the Bing Chat screen. It says, would you like it to be corrective or would you like it to be unique? So this is really where you're key to really understanding what that flexibility is around that T, the temperature. So how creative is the right thing? The more creative basically means you're going to accept a lower probability score. So your actual output then is going to be a bit more randomized. So again, just always when you're playing with Chat GPT, all these things, just have a play with those just to see the difference in what it's making. But it's actually looking at a set list of returns and the probability of those returns.
Yep. So moving to the last but not least thing that we will be talking about today, which is the top probability. So in this next technique, instead of sampling only from the most likely word, I'm going to choose a pool of top probabilities. So to give you like a brief or like a simpler form of how it works. So I set a top probability and say that again, I'm using another threshold here, which is the top probability threshold for me. For us here in the first diagram, our top probability or our threshold is 49%. So any word that has a probability of occurring lower than 49%, it's not going to be in my pool. But any word that has a probability of happening after, sorry, more than 49% is going to be in my pool of selection. So let us take it for the word the. So again, if we are selecting from a pool of words that might happen after the word the, you can see that there are lots of words that might happen after the word the. That's why it only like lowered the cat a little bit, but all the words gets to be chosen from and be a word that might happen after the word the. But in the next selection process or choosing the next word, you can see how the top probability shines. Because instead of having to select from all of these words, which are words that might happen in a pool of 10 words or 9 to select from, I have set the top probability for the next one to be 79%. So instead of having to select the car stops, the car is down, the car is the car is not, the car is small, so on, I'm selecting from only these 3 options. The car drives, the car is, the car turns. So I have lowered the probabilities for the words that might not come very often after the word the car the or the sentence the car the, but I have made the other ones shine more. So I'm selecting from the top probabilities. So it's just how the name suggests. I'm just making my pool smaller to select from the top probabilities. And that's like basic top probabilities, how it works. So I think we're done for this part. And we can move to Lee again and learn about
Thanks, John. So so we've gone over the theory there of what machine learning models and how machine learning works in terms of an LLM context. So what we're going to do now is move on to the scenario. So our scenario is going to be creating a writing assistant. This is something lots of people want. So it's really about how do you create a simple application. So we're going to be using Power Apps to build this application to create a simple writing assistant that's going to use either ChatGPT, or it can use one of the GPT model or one of the LLM models which are available in Azure Machine Learning Catalog to actually feed those prompts. So if we look at some of the different models that are out there today, there's open source models such as Llama 2. So this is a great example of an open source model. And they have, again, different contexts and benefits of where they can be utilized. So Llama 2 is great because it's open source. It's great being used in commercial and academic purposes. It's really aimed at targeting English language applications. So it's not very good at translation yet. And it's great for building things like functional chat assistants or what we call bots, where you can actually interface to. Again, you need to check the limitations of these models from a licensing perspective. So make sure that whatever you want to build these models is responsible in its AI. So think about responsibility at the onset of building the application. What is your application for? Is it a responsible use of AI? Does it breach any legal standards? Does it trade laws, etc.? Again, it's really aimed at English language, so that's really key. And again, make sure you do abide to any terms and conditions that the language models offer. So Llama 2 is a great one. It's come from Meta and it's open source. Another great model is GPT. So GPT is now all the way up to level 4. We're going to start with GPT-2. It's a very, very lightweight model. That's one of the massive benefits of it. And it's great for things like research and practitioners who want to understand things like bias and understand getting started with large language models. GPT is really great at doing grammar. So we want to write something. So we're going to be looking at a writing assistant, and it's great auto completion because it understands those temperatures and probabilities, and it understands prose, and it also understands code. OpenAI GPT model is what GitHub Copilot is based upon, so it understands all different types. It's also great at doing creative writing and exploring the generation of fictional text, because that data has been loaded into the model as part of the machine learning model process of the model being created. And it's got loads of use cases from games, chatbots, etc. So these are the two LLMs that we're going to utilize. There is hundreds of LLMs out there. And again, we're going to show you that within the Azure Machine Learning catalog, that these models are available. And what's really cool about this is the catalog is a snapshot of those models. So this is a model in a private instance. It's not using the public model, it's using a private model within your Azure subscription. So this is the full architecture of what we're going to be building. As I said, we're going to have Azure, and we're going to have Azure Machine Learning Workspace within a resource group within Azure. We're then going to have our model deployed within that resource, and we're going to have a compute instance to power the model, and then we're going to have some code that we want to basically provide an endpoint to the application. So that's going to provide a real-time endpoint, so basically an API to our model, which the application can then consume. What we're going to do is we're going to build a Power Platform application that's going to use Power Automate to interface with the model. So it's going to connect to the model. And then we're going to have a Power App that's going to surface that connector, so using the flow into the API for then the user to interface with. So the user will go to a page on an application, be able to type in some prompts, and then get back an answer to that solution. Excellent. So let's talk about how LLMs are being deployed. So back to you, John.
Yeah, so the two LLMs that we are going to use, as Lee mentioned for you, can we move to the next slide, please, are GPT-2 and Llama 2. And GPT-2 are both large language models that are autoregressive models that are decoder-only technique. So both are the same in so many aspects, but what makes them different is how they were trained and the data that they were trained on. So that's what we are gonna talk a little bit about here. So GPT-2, the size of the different models are ranging between from 142 million till 105 billion parameters. And 105 billion parameters, I think, is the GPT-4. So that's not GPT-2. So these are the GPT family and the Llama family. And for the Llama 2, it has the 7 billion one, which is the one that we are going to use. But what is this different parameters? It's the complexity of the model. But again, what does complexity mean? It's the architecture. So when I have a more complex architecture, I am dealing or working with different or more parameters. So that's what makes or distinguishes different large language models from each other is two things, the data and the architecture. And again, if you see a larger number of parameters, it's a more complex architecture or bigger architecture. And if you see data used from X or Y or Z, then it is going to be as good as the data it has been given. So for GPT-2, it has been trained on something called web text, which is data from Reddit, and it's subreddits that have more than 3 kudos. But for Llama 2, they say that they trained it on a new or publicly available online data set from the internet, from everywhere, but they don't disclose what type specifically. For the capabilities, GPT-2 is able to do fiction, to do creative writing, entertainment purposes, but Llama 2 can do the commercial stuff. So you might use it in your business, and again, it can do the entertainment as well as this stuff. GPT-2 is public, anyone can see it, can use it, but to have full access to the code itself that is used to make the model, you have to pay. And for Llama 2, it's public and it's open source, so anyone can go and sign up to receive access on GitHub to see what is Llama 2 content of the model. Next slide, please. Next slide. So what is this Llama 2 model? So Meta, which is Facebook, previously have developed this model, and this large language model, as I previously mentioned, has three different families: the 7 billion, and I think it's the 14 and the 70 billion parameters. And that's what 7p that you see beside the model signifies. So you don't like it, or 13 billion, yeah. So you don't like, you have, what is this? And next slide, please. So yeah, as I previously mentioned at the beginning, any language model that deals with text, it's going to accept only text input, and it's going to give you back more text. But this more text can be anything. So it's going to be a summary, it can be completion, it can be code, as Lee mentioned, anything you can imagine. And again, it's an auto-regressive model, and we know what are auto-regressive models from Lee's explanation previously. And it has been trained for data that are up until July 2023. So it's not going to be able to answer questions that have been raised after that, because it's not like they are continuously updating it, but the deployment that we use is based on these specific data. If you want to get something that is more updated, you can use Bing Chat. Can you go to the next slide, please? I think it's the demo tab. Next slide, please, Lee. Okay, great.
Sorry, let me just get my environment started. So just to sort out the subscription.
Okay. So until Lee gets his subscription up,
there we go.
Yeah, great. Now we have it.
Sorry about that, everyone. The joy of life. So yeah, so what we're going to do now is actually go through the deployment of an Azure subscription. So first thing which you do need is you need to create what is called an Azure resource group. So an Azure resource group is basically a collection of all the different resources associated to your environment that you want to build. So we always recommend that you should create a resource group for each individual project that you create. This really makes it easy for you to manage those resources and delete those resources after the work item has been completed. This is really key because you don't want to have resources with actual services running, because it will cost you money and that will then impact your available budget. So number one, we're going to create a resource group. The second thing we're going to do is we're going to create an Azure Machine Learning Workspace into that resource group. Now, this is, again, we want to create a machine learning workspace associated to that resource group to then carry out our experiments. What's really cool about Azure Machine Learning Workspace is there's a tool called Azure Machine Learning Studio. And we're going to be utilizing Azure Machine Learning Studio to build our LLM and the endpoints to our LLM. And what's available within that service is a great thing called Azure Machine Learning Catalog. And I'm going to pass over to John for him to talk about what Azure Machine Learning Catalog is.
So the catalog has different models, which are called foundation model. It's something new that Microsoft introduced recently, and it's models from 3 different sources: Meta, from Azure ML, from I think Hugging Face. So you get all the open source projects that are out there, and you can use them from Azure Machine Learning Workspace. Just click on the button and it works. Next slide, please. So what are the most important things that we need to do? when you click on each model, so for example, if we take Llama 2 and you go all the way down, you can see the input text that you need to give it in order to get this sample output that you see in front of you. So this is the most important part in the model page. So after you click on deploy, we need to focus on this part because this is the part that is going to enable us to use the model. Next slide, please.
There you go, John.
So again, once we get the model deployed, once we click on deploy and we have our model deployed to an online endpoint, which is basically an HTTP server that takes us or takes the input that we send it and it gives us back the output, which is the prediction. We have to click on consume in order to be able to use our model. Next slide, please. I'm moving back to Yuli with the full architecture that we are going to deploy.
So what we're going to do now is we're going to have we've got a Microsoft Azure subscription. We're going to create a resource group. We're then going to create an Azure Machine Learning Workspace. We're then going to create the machine learning model that we wish to use. And we're going to deploy a GP2 machine learning model. We're going to give it some compute, and we're going to give it the endpoint, which then John will be able to connect to with his Power Platform application. So what are the prerequisites that are needed for this implementation? John, do you want to give us a quick overview of these?
Yeah, great, of course. So the prerequisites that anyone needs in order to follow along with us is an Azure subscription. You can get it for free using the aka.ms/Azure for students, which is open for everyone. Any student can use his or her college account and sign up to get access for 1 year on the Microsoft Azure platform. And there is something that is really amazing, which is the Microsoft 365 developer subscription. You can go to aka.ms/m365 student dev or stud dev. I don't know how to say it, but you can see the link. So just go there, sign up, follow the information on how you can sign up, and you can get access to Microsoft 365 apps like Power App, Power Automate, and so much more. The next thing, which is that you have a working Power Apps environment. And in order to do that, just go to this link, aka.ms/ppcomdev. And this link just gives you a small information about what is the Power Platform environment or Power Apps environment and how you can create it simply. It's just click, 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 create, and give it a name. That's it. And finally, the most important thing in order to be able to run this solution is our solution zip file, which has the Power App and Power Automate budgeted together, so you can use it on your own Power Apps environment. Next slide, please. Can you switch to my...
There you go, John.
Yeah, great. So
what we're going to do now is do a practical deployment of a large language model to the Azure Machine Learning Workspace. So what we want to do is we're going to open up our Azure Machine portal and sign in. We're then going to create an Azure Machine Learning Workspace, and we're going to deploy the model using the large foundation. So we're going to actually choose the LLM GPT-2 model from the catalog. So what we're going to do now is we're going to go into a demo and we're going to deploy an LLM. And I've got a massive issue with my subscription at the moment.
Yeah, I see. I told
and that's
you.
what I've been trying to fix. Sorry.
I had deployed another one in the background.
Have you got another subscription, John?
Yeah, I have. But
let's go yours. Do you want to switch to your screen?
Your subscription is working now.
Oh, is it? Cool.
Yeah.
It says disabled still for me.
Oh, just refresh the tab. So what Lee's gonna do with you right now, he is gonna try to deploy a large language model, and it's so fitting that the subscription is deactivated as the day of the demo. So it has been working for months, but it comes and like stops like at the day of it.
John, if you can just share it, because it's not working for me.
Okay, no worries. So can you switch to my slides, Erica? Or my screen? Yeah, now we are, you can see, all of you can see my screen. So again, this is just a reminder of the steps that we are going to be performing. Give me 1 second for the Microsoft Azure to open. And yep, now we are here. So again, just open your Azure portal, sign in by going to portal.azure.com. Like you can do the talking, Liana. I'm gonna do the steps for you. It's better that way, right?
Cool. It's still loading, so just give it a second. So apologies of this, everyone. The joys of live demos. Cool. So we're now into the Azure portal. So what we're going to be doing here is we're going to do exactly what we said. We want to deploy an Azure Machine Learning Studio environment. So we select Azure Machine Learning service, Azure Machine Learning, which is the services at the top. We're now going to give it a resource group name. So what we're going to do is we're going to deploy a GP2 model here. So we're going to call this GP2. And John is giving it a resource name. So we're going to, as I said before, we're going to add everything to a single resource group because we want to manage that resource group to then manage the costs. We're going to give it a workspace name. We're going to call it GP22. We're going to actually use the region of central US to deploy this. So what we should be doing when you think about regions is deploy these technologies and services to the region which is closest to you. So in this case, central US is closest to me, and we're going to deploy that service there. We're going to review and recreate that, and then this is going to create our machine learning model space. So hopefully this should work. Which is great. It's deploying.
Yeah. So while it's working on the deployment, we can continue with the this workspace, which we have created for the demo. And Lee can go or walk you through how you can deploy the GPT-2 model here.
Yeah, so this is what we call the Azure Machine Learning Catalog. So this is basically a catalog inside the Azure Machine Learning Studio, inside Azure Machine Learning, which allows us to choose any LLMs that are available. So as you can see, it's displaying what are the most common LLMs that are being used. So you've got things like the Llama 2 model. In here, we can actually search, so do an actual search at the top of the screen for GPT-2. Now, this is going to bring back all the models that currently exist within the current model catalog. So any developer can upload their models to the catalog to make these available. So people like Hugging Face, Azure itself have deployable models in this catalog. And each of the model is then represented underneath the search output with an icon that represents the vendor or provider who has provided that model. And you can see there is a collections icons at the side of John's screen on the right, which identify which model those providers have come from. So in this case, we've got GPT with a green tick, which basically is an Azure service, and there is some with the Hugging Face service as well. We're going to deploy the GPT from Azure, and that's going to deploy this service now. So this is taking a snapshot of GPT-2, storing it within your Azure subscription. So now we can run a test in the sandbox. So the query example is my name is John. We can hit test on that and it'll give us an output based on the GPT-2 model, which is a textual model of a story around my name is John and this is what I do. So this proves that the model works. Again, you can change that query input. We're happy with this. All we want to do is deploy it. So we can go up to the top and simply select deploy with a real-time endpoint because we want an endpoint for the application. Set the compute size that we want from terms of compute. So in this size, we're just going to choose a standard DS. This is really cost effective. We can choose other size machines if we wish, and we're going to deploy this now into our environment. So we click the deploy button, and this is now going to deploy the model. So it's taking a snapshot of that model, sticking it inside our private Azure subscription, and building the compute infrastructure around that model to then allow us to do compute on the model from the prompt. So whatever prompt we provide, the compute will then look at the model, do the probability, do the temperature, and provide the output back. So John's just deploying this now, and then that's our environment deployed. So within 3 clicks, around 5 minutes of time, we have a deployed model available in our Azure subscription. Thanks for doing that, John.
Yeah, anytime.
So if we look at the next section, we've done our deployment of the actual model. So we've got our Azure environment with our resource group, with the Azure Machine Learning Service, with Azure Machine Learning Studio, with the GP2 deployed model available now. So what we're going to do now is look at the deployment of the Power Platform solution. And this is the architecture side we've done. So everything on the left has been completed. Everything within the box is now what we're going to do. So we're now going to build the application, the Power Automate flow, and connect to that endpoint. And that endpoint is just simply a URL with a key. You know, there's nothing. This is all available in the portal, and it will show you what to do. So a quick overview of what Power Apps is, John.
So Power Apps is for business application with a simple UI. You can drag and drop and create cool designs for your businesses, and you can learn more using this link. And it's really targeting all the business users out there who don't have strong coding background to start their business and have a fully functional application that can be connected to many databases. And I think many things you can automate also using the Power Automate. In the next slide, please. Oh, I'm done doing the slides. So Power Automate, which works with Power Apps and lots of other stuff, you can do and go and again drag and drop. It's a low-code solution, so I can drag and drop and create lots and different automations, whether it's a desktop automation, it's a Cloudflow automation, whatever type of the automation I want to create, I can create it, and simply by dragging and dropping. And again, it's connected to different, for many applications, using its huge connector library. So you can, I don't know, you can do it integration with anything, I think. And again, moving back to the architecture, I think Lee is gonna.
Yeah, so as I said, what we want to do now is we want to build a Power Automate flow, which will connect to our endpoint. So it's going to connect to our URL, and it's going to pass a message. So the run help me flow is going to look for an input string from our Power App. So that's the only command we need to put in our Power App, is we want it to do that run help me write and flow, and then the input string is what the actual text will be, and that's going to pass it to the LLM and give the output back to the user. So very, very simplistic. This is what the app looks like. It's simply a text box and an output box. The text box is where we're going to add the code to call the API, and the output is where we're going to send the response from the API back, and the generate button is going to do the actual command to process it. This is the command that is used to actually trigger the flow. So as I said, it's very, very simplistic. It's called PowerFX, this language. Now, this is very simple. It's very similar to anybody who's done any Excel programming with the PowerFX languages. So all you're doing is actually creating a set of helper functions that are being called, and the run command is calling that function, which is then going to give a JSON output, and you're going to give it an input string, which is a text. So input one dot text is the input that you put in the text input one field in your Power App. Very, very simple. Nothing complicated about this.
And I think I'm going to walk you through the Power Automate Cloud Flow right now, which is doing everything. The Power Apps just sending the text that it gets from the user to the Power Automate, and Power Automate is what has been doing all the work in the background. So now you can see this is Power Automate Cloud Flow that we are using. So it just initializes some variables, and these variables are the API key that you can get from the Consume tab on Azure Machine Learning, and the endpoint, which is the URL for the deployed model on Azure Machine Learning. And then it stores an output message. This is initialization for the variable. It's just an empty string. That's what we are going to be returning. And the first thing is that it gets this prediction input and parse it as JSON. And then after parsing it, we define here a schema to make it in this form, which says there is something called input string in this JSON object, and the type of it is a string, and that's it. And then after parsing this input text, what are we gonna do is that we are either gonna invoke it or send it to the endpoint and make an HTTP request, or we are gonna send back an input error because it couldn't parse your input. So in order to invoke it, the only thing you need to do is to initialize your variables here, which are just the URL that you are sending the request to, the authorization, which is the key that gives you access to this endpoint, and then the body that I told you that this is what we need our sample input to be in the shape of in order to get predictions. And then if there is a problem with making this request, it's going to give us an endpoint error, or maybe it worked. Then we are going to get the prediction back from the endpoint key, and we are going to return the output, whether it's an error here or an error there, or the actual prediction to Power Apps again to display it. Back to you, Lee, with the slides, if we can. If we can't,
yeah,
let's move.
So I think what's really cool about the Power Automate solution is it's really excellent. It's just basically about automation. That's the whole focus of what Power Automate does. It's about taking a process that used to be done in a manual way and building a flow which basically breaks down each of those tasks. So as John said, we want to take an input, pass it to the API endpoint, get the JSON back, and then pass that JSON back into the application, or provide an error back to the application if there is no response. So what we're going to do now is a practical integration of the endpoint with the Power Platform app. So we're going to focus now on just this middle section of joining the Power Automate flow with that endpoint. So exactly what John went through there in terms of the screens. So first step is to open Power Apps and import the solution. You can then edit the Power App flow, and you can then test and publish the application. So John, over to you for the demo. Johnny, on mute.
Sorry for that. So in order for us to do this, as Lee have mentioned, we are going to focus on the middle part. And let me share my screen. So I told you before that when this model is deployed, you have the endpoint and the API key. And these two things we are going to take and plug into the solution here in the API key and endpoint. And of course, I'm not going to show you, but how can you obtain this specific solution, which are the steps that he mentioned previously. Just go to make.powerapps.com and click on the word solution. And now just import a new solution. And I think that I'm in the apps one. So let me just try to click on the solution in order to get the button to import a new solution. And you can see it here, import solution. And now there is a zip file that you can find on GitHub on the repo that we have sent previously. You are gonna take this zip file, download it, clone it, whatever way you want, and just click on browse, locate it on your PC, maybe it's on your desktop, wherever it is, and click on next, import, okay. And now you have imported the solution. So once you have this solution imported, you can open it like that. Just click on its name. So this is the name of your solution. Now, what you are gonna wanna do is that you are gonna want to click on the app itself to open it. And then after you open the app, this is the screen that you are gonna see, which is the application screen. And the next step is to click on Power Automate here from the left side menu. And let me enlarge this screen a little bit, just a little bit, okay? Now let's click on it and click on Edit. And now you can add your API key, the ones that I told you to get from here, into your Power App and endpoint here and hit the Save button. I have already done that, so I don't need to do it again in the background, okay? So now it's refreshing my solution and it's picking up the Power Automate flow has been changed, and we need to save the app because we have done some changes to the Power app. And just wait a little bit. And once it's ready, we can click on this play button to preview it and test it out. And let's pray it works because we have encountered lots of problems today. So hello, my name is John. And I'm gonna click on generate and yeah, woo! I'm so happy that it worked. So it works. You can see that it gave us back some text based on our input text. And that's how you can do it. It's a simple solution that we did with just a bunch of clicks. And you can do it yourself too. And I think now we need to get a look on the full architecture that we have built together. So Lee have gone through building the architecture or the application on on Azure, on Microsoft Azure. He has deployed a real-time endpoint, and he has, I think that's what he did. He didn't do anything else. And on the other side, we have imported the Power App. We have linked between the Power App and Power Automate, and that's what enabled it. Enabled Power Automate to send a request to the real-time deployed endpoint using the API key and the endpoint URL, and it got back a response. And this response we have formatted again and displayed it in Power App. And he's going to walk you through the summary.
Yeah, so the key things are, what we've tried to really do today is show, number one, that machine learning models have a specific format for input and output formats. You've learned all about Azure Machine Learning Studio so that you can actually utilize those different inputs and different models. Hopefully you've understanding a little bit around the model deployment. So, basically what using the LLM model catalog allows you to do is to deploy an LLM and have a direct endpoint with that single deployment button. So we did a quick deployment, got an endpoint, got a key, and then we're able to connect to that as an API. We've then integrated that into a Power Platform application, but that could be any application because it's just an endpoint. So it could have been a web app if you're a web developer. It can be a low-code solution if you're a citizen developer.
And let me show you something here, Lee.
Yep.
While you're mentioning it, I forgot about this, but this is a really cool thing that the Azure provides you. So if you're using Python, you have a Flask app, you can take this this piece of code and put it, and it's going to work. It's going to send you requests. It's going to get you responses, but you have to plug in your data sample input, if you remember, and your API key, because of course they don't plug the API key for us, because for illustration purposes. So you have Python, you have C#, you have R, you have all of these languages that are ready for you. Just copy and paste, and it's going to work.
So again, this makes it really great as an application developer. Everything is provided for you, so it's very simplistic. And the next thing is really about how you understand the integration of Power Platform. Now, this is really using what is classed as a flow. So the flow is about how to automate processes. You can also use things like connectors. So there is connectors out there for OpenAI, for Azure OpenAI as well, which are directly to the public services that are available. What was really great about this demo is we had a private LLM. This LLM was private to us. So the messages we're sending to this LLM are within our Azure subscription. No one else can see it. We're not using any of the public data because it's a snapshot of that public instance. Next slide, John. So, what we've really hoped that you've done, is embrace the opportunity of large language models. They're very, very easy to deploy, very easy to consume. Hopefully you've been able to explore some of the endless possibilities that you can do once you deploy those with Azure, whether you want to start integrating those into your applications, whether they be web apps, whether they're Power Platform apps. And again, hopefully you've seen that, by doing this simple process, you can transform projects with AI and start to build amazing AI solutions and really start to work on the future. So I know we're slightly over on time, but thank you. We did have some technical hiccups, typical, but here's a survey link. Please use the event code. We do want our feedback. There is lots of resources that are available on this on demand. We do have like a full walkthrough and a technical blog and a tutorial and a Microsoft Learn tutorial for this resource. So again, if you're interested in this more, you can go and do those additional learning resources and copy through exactly what we've done today. So a huge thank you. Do we have questions?
Yeah. I think I see a question in the chat, but I think you can follow the recording, Stephen. So you missed what we did when we used the Azure portal. So if you go back to the recording, you can see it. I know it was fast, but sorry for it's just because we faced some technical issues.
Again, that's fully documented, Stephen, in the walkthrough. So again, if you have any issues, the walkthrough does have all that.
So again, if you have questions, don't hesitate to type it in the chat, ping us on LinkedIn or on Twitter. We are going to love to hear from you about these events, these blogs, these types of things, because we are always curious to know your feedback. You're welcome, Stephen.
Hi, Leigh and John.
Hello.
Hey, thank you so much for this stream today. I don't see any questions, but yes, as John mentioned, this session is going to be available on demand, so you will always be able to go back, rewatch, and learn and continue learning.
Yeah, and we will add the additional resources in the description on the on-demand version as well.
Exactly, and if you signed up for this event, which I'm sure you did, you will also receive an email with all the links attached to it. So there's many ways to get your hands on to those links and continue your learning journey. But yeah, I don't think we have any questions. Oh, we lost John.
Oh, he's back again. He's back again.
Oh, he's hungry. He's going for dinner already. But yeah, thank you so much, guys. Looking forward to have you back at the reactor session, at another reactor session again in the future. Yeah. And thank you so much for today.
Thanks, everyone.
You're welcome. Thank you for having us. Bye.
Thank you. And thank you guys for joining, everybody out there. So have a nice evening or day ahead of you, based on wherever you are in the world. Take care. Bye.